problems based on what? It's a nature of work. Here just I'm taking about one question is if the force acting on a particle F bar is given, it's a 2I cap plus 3J cap plus K cap Newton, and displacement of the particle I cap plus 4J cap plus K cap meter. Okay, so here now you find work done. W. How do you find? F bar dot S bar. So dot product. So the product of coefficients of I. Coefficients of I, what are there? Just to check them. First, I 2 into 1 plus J 3 into 4 plus 1 into 1. It's a 2, it's a 12 plus 1. So 15 joule. It's a very basic level question. Like this will be asking. Now, second, one more I'm giving as one more question. This, just to take it as a force F bar is equals to 4I cap minus 3J cap minus 7K cap measured in Newton. Displaces, it displaces from A of 0, 1, 4 meter to B, it's a 2, 3, 2 meter. Okay, so then the work done by the force, work done by the force, okay, is what? Now the particle is displacing from, for example, this is the point A to the point B. Yes, it's a displacement. Now R bar means what? Otherwise S bar. Then what is it? 2 minus 0. So these coordinates are 0, 1, 4. Its coordinates are 2, 3, 2. So it's a 2 minus 0 plus, so comma, then what do you say? Otherwise vectorial I am writing as this. First one, 2 minus 0, 2 I cap plus 3 minus 1. What is this? 2 J cap plus 2 minus 4 minus 2 K cap. Now find the work done. W is equals to 4I cap minus 3J cap minus 7K cap. It's a dot product. 2I cap plus 2J cap minus 2K cap. Simplify. It's a coefficients of I 4 into 2 plus minus 3 into 2 plus minus 7 into minus 2. It's 8 minus 6 plus 14. 8 minus 6, 2. 2 plus 14, 16 joule. This is the work done. So, is the second model of the question. And for the third one, if I am talking about any two positions like, okay. So, next model of the questions are based on work done by a constant force. Problems based on work done by constant force. It's a problems based on work done by a constant force. It's a constant force. So what type of questions will be asking from this? So just what I'm giving the situation. If a body of mass 20 kg, just should think about, and it's starting from rest. On the mass, some 5 Newton of force is applied. Then what is the work done in first second or second or third second? Like we can go on this. So just I'm framing the question. A body of mass 20 kg is at rest. Okay, a force of 5 Newton applied on it. Calculate work done in first second. Calculate work done in first 1 second or first second is the situation. Now you try yourself, please. So generally we have that the formula for work done is W is equals to F into S. W is equals to F into S. So displacement is in the direction of force. Displacement S is equals to ut plus half a t square. Starts from rest. U is what? 0. So displacement d is equals to 0 plus half a t square. It's half a t square. A means what? F by m, correct? D is equals to half F by m into what? T square. So D is equals to, okay, so half as it is. Otherwise you can substitute here. F into F will become as F square. Or I'm substituting here F. The F is what? 5 Newton. Mass is what? 20. It's a 5 by 20. 1 by 4 into 1 square. It's a 1 by 2. 5 ones are 5. 4s are 1 by 4 into 1. It's a 1 by 8. W is equals to F is what? 5 into 1 by 8. Is okay. So this work done is what you say? 5 by 8 joule. Is the case. So like this type of questions will be asking. Now I'm framing a question based on this work done on along with the inclined plane. Okay, along with the inclined plane. Next model of question. This here just I'm choosing about an inclined plane. Let it be smooth inclined plane. It's a smooth inclined plane. And angle of inclination, just to take it about 30 degrees. A block of mass 10 kg. So moving with a constant velocity. V is equals to constant. Moving with a constant velocity. Now the question is about what is the work done? What is the work done while it's traveling 10 meter on inclined plane? Is the question. Started from rest. It's moving with a constant velocity. How many meters it traveled? It's 10 meters. W is equals to what? F into S. Which component of force is along with the inclined plane? mg sin theta. W is equals to, it's what? F into S. Is it okay? So F into S. So this is what you say, F into S means what? F means what you say here? mg sin theta, correct? So it's a mg sin theta into S. Okay, mg sin theta into S. Now you can substitute this. You need to get about, what's the answer you are getting? See, it's a 500 joule of work is done by the gravity. Work done by the gravity. The next model of question. So the situation is what? I am placing a block on horizontal surface. The force applied is what? Capital letter F. Its mass is what you say? 10 kg. Placed on the rough horizontal surface. Just you please observe carefully. Different forms of work I am doing this. It's pulled by a constant force. The force, let it be 50 Newton. Okay. The coefficient of, it is in the motion means what? The coefficient of friction should be there. That is what? Coefficient of kinetic friction is what? 0.4. Okay. Find the work done by frictional force. Work done by frictional force. When it displaces through up to this point, this displacement is what? Just to take about 5 meter. How do you calculate work done? Now when this is accelerating in forward direction, frictional force is what? Backward. Okay, it's a backward direction. So already you said it is in motion means what? I am using directly Fk. Fk is equals to what? Mu k into n. Mu k, n is what? Mg, correct na? So this is what? Mu k, n means what? Mg. It's a mg. So now the question will be, what is the work done by frictional force? Work done is what? Frictional force into displacement. Whatever that. Tensional force means what? Tensional force into displacement. Okay. So the work done by frictional force is what? Now frictional force is backward direction. Okay. So next one is that displacement is in forward direction and applied force is there 50 Newton. Is okay. So for this we need to do for the free body diagram. First I am taking about 10 kg. It's what? 50 Newton is acting. Frictional force is what? Mu k mg. What is the mu k? 0.4. 10. G is what? 10. So the answer is 40. Is the frictional force is less than applied force or more than applied force? Less means it accelerates. Okay, it is accelerating. Yes. So let me know on this, and again just I'm frame the question again. I'm giving idea. You can check it about a 10 kg block placed on rough horizontal floor. So it's pulled by a constant force. What is the force? 50 Newton. The coefficient of friction is given 0.4. Find the work done by kinetic friction acting on the block. Acting on the block. When it displaces through what? 5 meter. Okay, 5 meter. So for that, just again rewriting, you check it as this is my expected diagram. It's a 10 kg. My frictional force is this. Okay, applied force is this. Applied force we have 50 Newton. Frictional force we have 40 Newton. And what forces there again? Normal reaction N. Its weight is what? 10G means what? 100 are the things. Okay. So work done by frictional force is what? W. W is equals. So F into S. Already I said no here. This F into S. Frictional force is 40 into displacement is what? 5. It's a 200 joule. So sign convention minus opposite direction. Sir, here also again directly I can write here. Now you can write any different ideas. So this one also you are getting as what? 200 joule. So it should be what in negative, like will be mentioned. So this is one model of question. And next one, I am framing another question like two blocks. This type of questions were repeated earlier. So when the two blocks are connected by the inextensible string which is passing over pulley. Okay, so just I'm talking about this is the pulley. Yes, two blocks are connected by the string. It's what? 1 kg. Another one is what? Let it be, it's a 2 kg. Okay, this is heavier. So you know tensional force is what? Away from this, like this. It's the ideal pulley that you remember. Now my question is what? Question is different, that carefully observe it. Okay, so find work done. Find work done by tension. Work done by tension on 2 kg block. On 2 kg block. During the time interval. During the time interval. So 3 seconds. Okay. So after release. After release is the condition. Okay. Now you can see on this one. What is the work done by tensional force? After 3 seconds. Is it? After 3 seconds. Now, first of all, initially just to imagine these blocks are in my hand. Where is my hand? This is my hand. Yes. When I leave this, heavier one comes down, smaller one moves up. What came down with the same displacement moved up. Okay. With the what acceleration is moving downwards, with the same acceleration moving upward. Yes. So next one. So I want to know about this is what is asking work done by tensional force. Means again already said you work done means force. What force? Tension into what? Displacement. I should know displacement. What is the displacement? X. It's what? It's a X. Okay. So now you can check it on this. Now first one let me know about this what is X, and also let me know about this what is the tension. First of all, what is the acceleration? Acceleration A is equals to, already you know, F unbalanced, correct? Unbalanced force by total mass. Yes. So what is the unbalanced force? 2G is downwards. Okay. So this is what? 1G. 2G minus 1G by total mass 2 plus 1. Okay. 2G minus 1G is what? G. G by 3 is that 10 by 3 meter per second square. So I want to know about tension. So tension means what? You take any one body, draw its FBD. This is what? 2 kg. And it's a 2G. Tension is what? T. Acceleration is what? Downwards. Okay. So what is the formula for F net? Net force equation is what? 2g minus t. F net means what? MEA. MEA is what? 2a is equals to 2g minus t. 2 into a is what? 10 by 3 is equals to 2 into 10 minus t. So we'll write it about what is the condition. It's a 20 by 3, correct? 20 by 3, and I'm simplifying this one. Simplification must be very clear. T is equals to 20 minus 20 by 3. T is equals to 20 common 1 minus 1 by 3. T is equals to 20 common, it's a 2 by 3, correct? It's a 40 by 3. This is tension. 40 by 3 means what? It's a 4g, correct na? Okay, 4g by 3. Now, so work done by what? This tensional force. What is the displacement? Let me know the displacement. Displacement means what? S is equals to ut plus half at square. Okay, so displacement x means first you should know about S is equals to ut plus half a t square. X is equals to what? Started from just 0, half. What is the acceleration you had? 10 by 3. And what is the t ma? T is given is what? 3 seconds na? After 3 seconds, right? 3 square. So will become as what? 1 3 will cancel. 2 ones 2 5s. So what is the answer? It's a, what will be the answer? So it's a 5 half into 10 by 3 into 9. 1 3 cancelled. 15 15 meter. So what is the formula for work done by tensional force? This is equals to tension into displacement. Can you say, is it positive or negative? Tension acts upwards. On which body is asking? 2 kg, right? Isn't it? So displacement is downward. So this is what is equals to minus t means what? 40 by 3. X is what? 15. 3 ones 3 5s. What is this answer? 200 joule minus 200 joule. Is okay.